Good morning, everyone, and thank you for joining today's presentation. I appreciate the opportunity to discuss a strategic initiative that can significantly improve our organization's network performance, operational efficiency, and long-term scalability. As our business continues to grow and become increasingly dependent on cloud services, remote connectivity, and digital applications, the demand placed on our network infrastructure continues to increase. Today's discussion on how software-defined networking, or SDN for short, and software-defined wide area networking, known as SD-WAN, can help us modernize our environment while reducing costs and improve reliability. During this presentation, I will review our current infrastructure challenges and explain the proposed solution, examine expected business outcomes, discuss implementations, considerations, and conclude with a recommendation for executive approval. To begin, let's review our current networking environment. Today, our organization relies on a traditional networking architecture that consists primarily of routers, switches, MPLS connectivity, broadband internet services, and LTE backup links connecting multiple branch locations. While this design has served organization well over time, it was built for a different business environment. The network requires significant manual administration, and each location often needs individual configuration and management. As additional sites are added, complexity increases exponentially. This creates operational challenges for our IT staff and limits our ability to quickly adapt to changing business requirements. While redundancy exists through broadband and LTE connections, network intelligence is still largely distributed across individual devices, making centralized management difficult. These limitations are driving both increased costs and increased operational overhead. From an executive perspective, the organization is facing several interconnected challenges. First, network operating costs continue to rise, particularly due to dependence on expensive MPLS circuits. Second, the complexity of managing multiple locations increased the burden on IT resources. Third, scalability becomes more difficult as the organization expands. Our proposed solution addresses these concerns through the deployment of SDN and SD-WAN technologies. By centralizing management and introducing intelligent traffic routing, we can simplify operations while improving application performance and network reliability. The expected outcome includes measurable cost reductions, enhanced security, improved user experiences, and more agile infrastructure capable of supporting future business growth. Most importantly, this initiative aligns technology investments directly with organizational objectives. As our business continues to grow and become increasingly dependent on cloud services, remote connectivity, and digital applications, the demand placed on our network infrastructure continues to increase. Today's discussion focuses on how software-defined networking, or SDN, and software-defined wide area networking, known as SD-WAN, can help us modernize our environment while reducing costs and improving reliability. During this presentation, I will review our current infrastructure challenges and explain the proposed solution, examine expected business outcomes, discuss implementation considerations, and conclude with a recommendation for executive approval. Let's take a closer look at the challenges driving the need for modernization. Cost remains one of the most significant concerns. MPLS connectivity continues to provide reliability, but it comes at a premium price. As bandwidth requirements increase, costs rise accordingly. Performance is another concern. Employees and customers increasingly depend on cloud-based applications that can be affected by latency and congestion during peak usage hours. Operationally, many network changes still require manual intervention. This slows deployment timelines and increases the possibility of configuration errors. Finally, scalability presents ongoing challenges. Adding new locations often requires lengthy provisioning processes and significant technical effort. Together, these issues create barriers to efficiency and growth that must be addressed proactively. At a high level, software-defined networking separates network intelligence from physical hardware. Traditionally, each networking device makes its own decision and requires individual management. SDN introduces a centralized controller that allows policies and configurations to be managed from a single platform. For the organization, this means greater visibility, faster deployment times, improved consistency, and reduced administrative complexity. Rather than spending valuable resources configuring devices individually, IT teams can focus on strategic initiatives that create business value. This centralized approach also improves governance, compliance, and operational control across the network. While SDN transforms network management, SDN-WAN extends those same principles across our wide area network. SD-WAN continuously evaluates available connections and automatically routes traffic based on application requirements and network conditions. For example, critical business applications such as Microsoft 365, ERP systems, and voice communication can automatically receive priority routing, while less critical traffic uses alternative paths. This dynamic routing capability improves application performance while reducing reliance on expensive MPLS circuits. The result is more responsive, efficient, and cost-effective network that adapts in real time to changing conditions. This slide summarizes how the proposed solution addresses each of our major business challenges. High costs are reduced by decreasing dependence on premium MPLS services. Operational complexity is minimized through centralized management and automation. Performance improves through intelligent path selection and dynamic routing. Scalability becomes significantly easier because new locations can be deployed rapidly with standardized configurations. Finally, security is strengthened through centralized policy enforcement and consistent security controls across all states. This architecture enables the organization to operate more efficiently while supporting future strategic initiatives. The proposed architecture consists of several integrated components working together. At the center is SDN controller and SD-WAN orchestrator, which provides centralized visibility and management. Branch edge devices securely connect each location and intelligently direct traffic based on business priorities. Next generation firewalls provide advanced security capabilities, while cloud services and VPN technologies ensure secure connectivity for remote users and distributed applications. Together, these components create a unified platform that simplifies operations while increasing performance, security, and reliability. Several vendors were evaluated during this analysis: Cisco, VMware, Fortinet, and Open Daylight. Each offer compelling capabilities within the SDN and SD-WAN marketplace. After reviewing functionality, scalability, security, support, and overall maturity, Cisco Catalyst SD-WAN emerges as the strongest recommendation for this organization. Cisco provides a highly mature enterprise platform, integrated security services, extensive cloud connectivity options, and proven scalability for organizations of varying sizes. This recommendation balances current requirements with future growth objectives. As part of our evaluation process, we compared three leading SD-WAN vendors across five criteria that are most important to the organization: cost, security, scalability, cost integration, and overall management capabilities. Starting with cost, Fortinet offers the lowest initial investment. Cisco and VMware fall into the medium cost category, reflecting their broader enterprise features sets and supports capabilities. Looking at security, Cisco and Fortinet both provide strong enterprise-grade security solutions, while VMware delivers solid capabilities, but typically relies more heavily on integration with additional security products. When evaluating scalability, all three platforms perform well and support organizational growth. However, Cisco has a long track record supporting large global enterprise environments, making it particularly attractive for future expansion. Cloud integration is another critical factor as organizations continue adopting cloud-based services. Cisco and VMware both provide strong cloud connectivity and application optimization capabilities, while Fortinet offers moderate cloud integration functionality. Finally, from a management perspective, Cisco and VMware provide highly centralized administration, automation, analytics, and visibility. These capabilities help reduce administrative overhead and improve operational efficiency. Fortinet offers effective management tools but with somewhat fewer advanced orchestration capabilities. Based on this comparison, Cisco emerges as the most balanced solution. While it may not be the lowest cost option, it provides the strongest combination of security, cloud integration, scalability, and centralized management. For an organization seeking long-term value, operational efficiency, and a future-ready network infrastructure, Cisco represents the best overall strategic investment. This recommendation forms the foundation for the proposed SD-WAN architecture discussed throughout the remainder of this presentation. The benefits of initiative extended far beyond technology improvements. Financially, the organization can reduce recurring WAN costs while lowering operational expenses associated with network administration. Technically, employees experience improved application performance, increased uptime, and faster deployment of new services. Strategically, the organization gains a modern infrastructure capable of supporting digital transformation initiatives, cloud adoption, and future expansion. These benefits collectively strengthen both operational efficiency and competitive advantage. Successful implementation requires a structured and disciplined approach. Phase 1 focuses on assessment and design, ensuring a complete understanding of current state infrastructure and future requirements. Phase 2 introduces a pilot deployment to validate functionality and identify potential adjustments before broader implementations. Phase 3 expands deployment across branch locations using lessons learned from the pilot. Finally, Phase 4 focuses on optimization, performance tuning, and operational refinement. This phase approach minimizes risk while maximizing the likelihood of project success. Every transformation initiative carries risks, and it's important to address those risks proactively. Potential downtime is mitigated through pilot testing and phased deployment strategies. Employee resistance can be reduced through clear communication and stakeholder engagement. Skill gaps are addressed throughout targeted training programs and knowledge transfer. Budget risks are managed through governance controls and milestone-based project oversight. Finally, concerns regarding vendor lock-in can be reduced through standard-based architecture and multi-vendor interoperability strategies. With proper planning, these risks remain manageable and acceptable. Technology alone does not drive transformation. Leadership plays a critical role in determining project success. Leaders must communicate a clear vision, empower teams, and support organizational change. Innovation thrives when employees understand how technology investments contribute to broader business objectives. By embracing automation, cloud integration, and modern networking practices, leadership positions the organization for long-term success. This initiative is not simply a technology upgrade. It is an investment in organizational capability and future competitiveness. Perhaps the most important slide for executive decision makers is projected return on investment. Industry benchmarks indicate WAN cost reductions of approximately 40% through optimized connectivity strategies. Network downtime can be reduced by roughly 50% due to improved resiliency and automated failover capabilities. Deployment times may decrease by as much as 70% through centralized provisioning and automation. Additionally, employee productivity can be improved by approximately 25% through faster and more reliable application access. Collectively, these benefits create a compelling business case for investment. Based on the analysis presented today, I recommend moving forward with a phased SDN and SD-WAN implementation. This investment directly supports strategic objectives by reducing operating costs, improving network performance, strengthening security, and enabling future growth. The proposed approach balances innovation with risk management and provides measurable business value throughout implementation. By acting now, the organization positions itself to support future digital initiatives while improving operational efficiency across the enterprise. This concludes my presentation. Thank you for your time, attention, and thoughtful consideration of this proposal. I welcome any questions, feedback, or discussion regarding the recommended SDN and SD-WAN modernization strategy. I look forward to discussing how this initiative can support the organization's long-term growth and future growth.